look at some data and see if we can find any associations or any conclusions from the data that we see. So the two-way table displays data about 55 different locations. Scientists have a list of possible chemicals that may influence the health of coral. First, they look at how nitrate concentrate might relate to coral health, and then they've displayed it in this table. So you see that they've got some healthy and some unhealthy coral, and a low and a high nitrate concentrate, and they've listed out the number. So in total of everything, they've looked at 55 different locations. So now I want to look at a relative frequency table specifically created for each column. So you can see that we want to know, out of the low nitrate concentration, what are these percentages? And out of the high nitrate concentration, what are these percentages? So I'm going to quickly go in and calculate those. So my first question says, when there is a low nitrate concentration, which had a higher relative frequency, healthy or unhealthy coral? So if we look at our low concentrate, we see that the healthy is a higher percentage. So we could say healthy. And that's because 71% is larger than 29%. This one says, when there is a high nitrate concentrate, is there a higher relative frequency of healthy or unhealthy? So looking at high, we see that unhealthy is actually the one that is going to be the larger number because 81% is larger than 19%. Asked is, based on the data, is there a possible association between coral health and the level of nitrate? So if you look back at our chart, we can see that there is a correlation because 71% of the time the nitrate concentration was low and the coral reef was healthy, but it was only healthy 19% of the time when it was high. And you can look in the other direction as well. When it's high, 81% of the time it's unhealthy. When it's low, only 29% of the time it's unhealthy. So since these variables are very different from each other, there is an association between healthy and unhealthy and nitrate concentration. The next example we're going to look at is comparing silicon dioxide concentrate in healthy and unhealthy coral. So you can see that the percentages are already here, and we already have out of the total of how much concentration was in each, either high or low. So we want to know if there's an association for silicon dioxide. So if we look at this, the best way to look at it is when you have your columns filled out in totals, then we want to compare across. So if you see when there's a low silicon dioxide concentrate, that it's 44% of the time it's healthy. Well, when there's a high silicon dioxide concentrate, 46% of the time it's healthy. So these numbers aren't very different, and since they're not very different, that means there's not an association. So it's hard to tell the difference between either low or high because they're very similar to each other. We're going to look at another example to help us understand this a little bit better. It says that Jada surveyed 300 people from various age groups about their shoe preference. The two-way table summarizes the results of the survey. So we have either sneakers without laces, sneakers with laces, or shoes that are not sneakers. And then we have different age groups as to what they like. And then we have our totals here. So before we start talking about, is there an association between age and the type of shoe that somebody likes, we want to create our relative frequency tables, either using our rows or using our columns to help us see what there is. So I've actually gone ahead and done both ways so that we can see what's going on. So we see that if we know the age of the student, then we can see the percent of their preference. Or if we know the preference of the student, then we can see their age based on that preference. So looking at this different information kind of tells us a little bit about each one. So here again, our totals are the rows. And if we look across the rows, we see kind of this breakdown of our numbers. And we want to compare, okay, so here's all of our numbers based on 4 to 10-year-olds. Let's look specifically at preferring sneakers without laces for 4 to 10-year-olds, 11 to 17, or 18 to 24. So if we compare the different age groups with this number, we see that this one is a lot larger. So we could continue doing that all the way across, and we could see some comparison. We could see this is a lot larger. So you see that most younger kids prefer shoes without laces, while many of the 18 to 24-year-old people actually prefer other shoes, and you can see that in the percentages. So we could look at a similar situation here. This time we're looking at the column totals. So knowing out of everybody who prefers sneakers without laces, here's the breakdown of the ages. Or with everyone who prefers sneakers with laces, here's the breakdown of the ages. So then if we look specifically at the 4 to 10-year-olds to kind of see how they're broken up, you can see that the largest number of them is in the category of preferring without laces. And so if you look here, you can see these comparisons of the largest numbers. So for example, among the kids who prefer shoes that are not sneakers, a very small percentage of them is the 4 to 10-year-olds, which kind of follows with what we set up here in the other table. So is there an association between this based on the information I see? I would say yes. So some examples about why would be that the youngest group, you can tell from here, prefers shoes without laces. So you see that small number here, that big number here, so kind of showing that proof. The middle group prefers shoes with laces, so you can see that these numbers are circled here because they're the largest in those preferences. And then the oldest group prefers the other shoes. So since there is a difference between it and it's not, the numbers aren't super close together, then that means that there is an association.